Okay, so we're going to look at the second fundamental theorem of calculus. Basically, what happens is we are normally looking at integration with two constants, a and b, of a function. Well, the second fundamental theorem says what happens if I'm looking and I want to integrate, instead of going to a constant, I want to go to a function in terms, let's say, of x. So when we do that, we change the integrand, the part inside, to a t, just so the two x's don't get confusing, because that is confusing. So this is what the second fundamental theorem looks like. It says we're going to find the antiderivative, or the area, accumulating area, from a constant to x, a function of x, f of t dt. So let's first kind of talk about what that looks like, and then I'll show you, after many years, what was figured out with the second fundamental theorem. So let's just start with this. We're going to integrate from 2 to x, and we're going to use t cubed plus 6t minus 3 dt. So we're going to integrate that just like we've been doing. It's a definite integral, so we're going to integrate. So if I integrate this, it's going to be t to the 4th over 4 plus 3t squared, because I divide by 2, minus 3t. And I'm going to integrate from 2 to x. So now we're going to plug x in, because that's our top boundary. So I have x to the 4th over 4 plus 3x squared minus 3x. And then I'm going to subtract when I put 2 in. Oh, I hope it comes out nice. Let's see. 2 to the 4th is 16 divided by 4, so that's 4 plus 12 minus 6. I think that's 10. So our antiderivative is x to the 4th over 4 plus 3x squared minus 3x minus 10. That's our f of x. So what we did is we got a new function in terms of x. So let's try a couple things. Let's use this new function, and I want to find f at 2. How would you find f of 2? Well, you would plug 2 in here. So you'd get 2 to the 4th over 4 plus 3 times 2 squared minus 3 times 2 minus 10. So you can get out your calculator. This is going to give me 0. I can explain why I get 0 so quickly. How do I know that's going to give me 0? Well, if I put 2 in for x, go back up here. That means I would be integrating from 2 to 2. Do you remember that property? If your a and b are the same, it's 0. So there's one of those properties that are good to remember. Let's try another one. Let's integrate f of 6. Will this one give me 0? No, it's not. It's going to give me a bigger number than that. Oh boy. Hold on. All right, so if I put in 6, I get 6 to the 4th over 4 plus 3 times 6 squared minus 3 times 6 minus 10, and that's 404. You can check my math, but I did these earlier to make sure they worked. So that's one thing about the second fundamental theorem. Basically, when I'm taking a function and I'm integrating 2x, it's giving me areas added up. So f of 2 was 0, so that area is 0, but f of 6 gives me 404. It's a big area. Okay, let's try another one. Let's look at if I want to integrate from 3 to x of t plus 2 dt. So I'm going to find a function in terms of x. So when I integrate, I get t squared over 2 plus 2t. And then I'm going to integrate from 3 to x. So again, I get x squared over 2 plus 2x. And then I'm going to subtract. If I put 3 in there, that's 3 squared over 2 plus 6. 2 times 3 is 6. And whatever that constant equals, that's 9/2 plus 6. So what would happen, because here's where the second fundamental theorem gets kind of cool and it makes it easier. What happens then if I have this function and I take the derivative of it now in terms of x? What would be the derivative of this function? So if I take the derivative of this, so remember derivatives were what we did the first semester, the derivative of this would be 2x over 2 plus 2, and the derivative of a constant is just 0. So this would give me the derivative is x plus 2. Notice this x plus 2 is the same function as t plus 2, just a different variable. So that gets into the important actual theorem of the second fundamental theorem. The second fundamental theorem says if I take the derivative in terms of x, that's what I just did there, of a function where I'm integrating from a constant to x in terms of t, you don't have to use t, but almost every calc book does. If I do the integration and then I take the derivative, I get the function back. This function, I get it back, but in terms of x. That's what happens. So you could do this with lots of different functions. So like if I'm going to go from -4 to x of the square root of 3t to the 4th plus 5 dt. I could find the antiderivative of this and then take the derivative, or I know the second fundamental theorem. So I know that this is just going to give me the square root of 3x to the 4th plus 5. Again, just to make sure, what happens to this -4? The derivative of -4 is 0, so you don't have to worry about that. And I put in x. I should be taking the derivative of x because I am doing derivatives, right? Because it's talking about the derivative. But what is the derivative of just x? It's 1. So technically you're multiplying by 1, kind of like that chain rule that we did. So when I multiply by 1, I get the same thing. Just real quick, you could do this with sine and cosine as well. So if you have from pi over 2 to x of sine of theta, maybe they use theta instead of t, which that could happen. When you do that, you would, and you're going to take the derivative of that in terms of x, you would just get the sine of x times the derivative of x, which is 1. And remember, this is a constant, so its derivative is 0. Like I said, you can do that for anything. Then the question comes up, what happens if this is not x? Well, let's talk about if it's not just x. So if I'm using the second fundamental theorem and I want the derivative, so I'm looking for f prime, because I believe on your WebAssign today, they don't use it as d of dx, they look for f prime. So remember, the derivative and f prime are the same. So if I'm looking for f prime, and I have from 3 to x cubed of 4t dt. And I'm looking for the derivative. So that means I can just plug this x in. So I get 4, and I'm going to get x cubed squared, because I'm putting x cubed in here. But on this one, because x is not just x, so the derivative's not 1, you still need to multiply, right, by the derivative of x cubed. So that's going to be multiplied by 3x squared. So if we do all this, 4 times 3 is 12. So my derivative is going to be 12x. There's 6 here and 2 here, so that's to the 8th. What happens to the 3? Well, its derivative 0. So I could put that in here, this 3, but when I multiply by its derivative, so I could have 4 times 3 squared multiplied by the derivative of that is 0. But don't waste your time. So if it's a constant, just remember its derivative 0, and you're looking for a derivative. All right, let's try another one. What if you just have like from 1 to x squared of 1 over t to the 4th dt, and you want the derivative of that function. and I want the derivative of that function. So I would have 1 over x squared to the 4th, but I'd have to multiply by the derivative of x squared, which is 2x. So it would be 2x over x to the 8th, which is not correct in calculus. That would be 2 over x to the 7th. So that would be my derivative. How about one more? What happens sometimes? You might have both the top, the a and the b, be functions of x. So if you are looking at this and you're looking again to find that derivative of this, you could take the antiderivative and get like t squared plus 4t and put those in and then do the derivative. So you could start again by getting the function and then taking the derivative. Or you can use the second fundamental theorem and you can plug in your values. So you'd have 2 times x plus 3 plus 4. Again, what is the derivative of x plus 3? It's 1, so you don't have to multiply it by anything. And then we're going to subtract. We're going to put in x, our bottom boundary, 2 times x plus 4. What is the derivative of x? Its derivative is 1, so you don't have to multiply by anything. If you simplify this, you get 2x plus 6 plus 4 minus 2x minus 4. Your answer is just 6. That's it. So that's a quick version of the second fundamental theorem. It is something that you do see on calc tests quite a bit, especially the AP test. And I really don't know if it's on the WIT Common Assessment. And as of this point, on the 21st of March, I don't know if we have to take it. They're still deciding. So, all right. Make sure that you get to the assignment on WebAssign, and that is all.